algebra. So here we have some polynomials. I have 3x squared minus 4x plus 5, and I want to divide it by x minus 2. If we use the same idea that we did for long division, so I'm taking 3x squared minus 4x plus 5, and I want to divide it by x minus 2. In the same way that we went in our numbers, we went from left to right. In the first part here, we got to 27 and said, how many 13s fit in 27? There was 2 of them, which is the closest we could get to 27. We do the same thing when we get to polynomials, except things work out even nicer. If we're going from left to right, the biggest number that we have in our polynomial, I'll underline it in black, is 3x squared. And so we ask ourselves, is there something that I could multiply x minus 2 by to get a 3x squared? And there is. If I wanted to get a 3x squared by multiplying something by x minus 2, I would have to multiply by 3x. Can you see that if you multiplied 3x by x minus 2, you would get a 3x squared? And so what we do is we write 3x up here, and we write it above our x column, just like in our numbers, we wrote the 2 over our hundreds column because we were really writing 200. And 200 times 13 was 2600. Same thing here, we write our 3x over our x column, and when I multiply 3x times x minus 2, I get 3x squared, and 3x times minus 2 is minus 6x. And just like we did in long division, we subtract. So I put brackets around it because I'm subtracting the whole thing. And sure enough, my biggest value goes away. And negative 4x minus a negative 6x is like negative 4x plus 6x becomes plus 2x. Bring down the 5 because 5 minus nothing would still be 5. And now we have 2x plus 5. And just like we did with our long division, right? In our long division in our first example, now we looked at 148 and said, what's the biggest from left to right? There's a 14. There's one 13 that goes into 14. With our example, we now look from left to right and say, what's the biggest value? It's a 2x. Is there something that I could multiply x minus 2 by to get a 2x? I would have to multiply by a 2. And so 2 times x minus 2, sure enough, I get my 2x. And 2 times negative 2 is minus 4. And we subtract again. 2x minus 2x is 0. 5 minus a negative 4 is plus 9. That's your remainder. So let's do another one together, just to see if we can get used to this pattern. Because what's happening is we're doing the same thing over and over again. And what I've done with my colors is tried to color code it to say, I did it in black, got an answer, then I did it again in green, got an answer. So in this next one, we've got 2x cubed minus x squared minus 2x plus 1 divided by an x plus 1. And just like before, we go from left to right, and our biggest value is a 2x cubed. And we ask ourselves, is there something I could multiply x plus 1 by to get a 2x cubed? What would that be? So to get that 2x cubed, what would I multiply an x plus 1 by? I need to multiply by a 2x squared. And because it's squared, I write it above the x squared column. Because what is 2x squared times an x plus 1? I would get 2x cubed, and 2x squared times plus 1 is plus 2x squared. Put that in brackets and subtract. And sure enough, that goes away. A negative x squared minus a 2x squared gives me negative 3x squared. And everything else would still be there when you subtract. Now my biggest value is a minus 3x squared. And so I repeat this process. My biggest value is minus 3x squared. What could I multiply x plus 1 by to get a minus 3x squared? And then we write that above our x column. Yes? So after we subtract, so at this point I'm doing 2x cubed minus x squared minus 2x plus 1 in blue. I'm subtracting this here. This minus this will be 0. Minus x squared minus a 2 will give me that minus 3x squared. And so now that I figured out that I need to multiply by minus 3x, I will get minus 3x squared minus 3x times the plus 1 will be minus 3x. Put that in brackets and subtract. Sure enough, we get 0. Minus 2 minus a negative 3 is plus 1. Bring down the 1, and we get x plus 1. Now our biggest value is an x. What would I have to multiply x plus 1 by to get an x? I'd have to multiply by 1. And 1 times x plus 1 is just x plus 1. When you subtract, that all goes away, and we have no remainder. So what does this mean? What have we done? What do the results of this dividing mean? Well, if we go back to our numbers and we think, when I divided 4,212 by 27 and I got 156, what does that mean? Well, that means that 4,212 is equal to 27 times 156, and there's no remainder. When I divided 2,748 by 13, I found out that 2,748 was equal to 13 times 211, but that wasn't quite right. It didn't work out perfectly. There was a remainder of 5, meaning that I would have to add 5 to this just to make it equal. It wasn't quite there. But I get two expressions that say what I got as an answer. So now when I look at this second one here with the remainder, because that one, in my opinion, is more interesting because it has no remainder, what does it mean? It means that, oh my goodness. It means that 2x cubed minus x squared minus 2x plus 1 is equal to x plus 1 multiplied by 2x squared minus 3x plus 1 with no remainder. And so what we've done, or at least started the process of doing, is factored this 2x cubed. Up till now, you've only been able to factor x squared equations. Or if there was a common factor, you know how to take that out. But you've never factored an x cubed equation. And with this long division, finding out that there was a remainder of 0 means that we factored that perfectly. And in fact, in this one, if you look at that second one, because you know how to factor quadratics, we could even say, hey, I know I can factor this even more. This would be 2x and x, 1 and 1. They'd both be negative in order to make that work. And we could factor it completely. And so one of the things that we're going to do in this unit is learn how do we use what we found out here to help us factor something that we haven't factored before. Like how do we factor 2x cubed? This one was nice because they told us to divide by x plus 1, and it worked out. But how do I find the one that works out? How do I do that? We're also going to find out how do we graph 2x cubed minus x squared minus 2x plus 1. Because we know how to graph x cubed with basic transformations, but we don't know how to graph an x cubed graph with x squareds and x's and extra things. So how can we use this information to help us graph? How are we going to use this information to help us factor? And that's what this unit is all about. Working with polynomials, learning how to graph x cubed equations when they're like this, x to the 4 equations, x to the 5 equations, learning how to factor them, learning how to find out if it is factorable or not, and how that works. The starting point is learning how to divide. So we start with long division. We can go to example 1 now. Oh, before we get to example 1, just so we can see it a third time here, your textbook has on page 3 another one worked out. How would you use long division for this? So we have x minus 1 and this. The very first step, you're looking at this x squared. Okay? And you're trying to figure out what I would have to multiply x minus 1 by to get x squared. So they're saying divide x squared by x. I like to think of it as what would I have to multiply this x minus 1 by to get x squared? You'd have to multiply by an x. So that's the very first thing that you write, is an x. Then you take that x and you multiply it by the x minus 1 to get x squared minus 2 and subtract. When you subtract, the next value gets brought down. And now you're looking at your new biggest term. Your new biggest term is 3x. Again, what would I have to multiply an x by to get a 3x? That would be a 3. And you repeat this process over and over again until you get a number that no longer can be multiplied to get it, and that will be your remainder. The quotient is your answer, the x plus 3, and the remainder is 8. Here is something that is super important, and I want you to highlight this. It is important that before dividing, we write the polynomial or the divisor in descending order. We have to write both of them in descending order. This never was an issue at the beginning with our numbers, right? Because when you're dividing 4,212 or 2,748, that's the only way you can write 2,748. You can't, if someone said, oh, you know what, I write, whoops, that's a very bright, I write 2,748 like this. Because I learned to write my thousands second, my hundreds first, my, what were these? These are my ones and these are my tens. Would that be confusing if we did that from now on? If we wrote our numbers in a different order? We wrote our hundreds, then our thousands, then our ones, then our... Would that confuse you a little bit? Like if I asked you then, what is 132 plus, let's be 0132 plus that, what's the answer? Well, let's make it more interesting. Let's make this an 8. If you had to mix up your numbers and learn how to add again, what would the answer to this be? One, 1, 1, 3. Right? Totally makes sense. No. But in numbers, we don't mess up the order because it means something totally different and would totally confuse us. I know that I always mostly confuse you because I'm teaching you math, and now I'm doing a really good job of doing that even worse, so I'm sorry. But with polynomials, like, yeah, ignore this. This is just messing your mind up because it's switching things around. But with polynomials, if you write 5 minus 4x plus 3x squared, you're probably pretty comfortable in saying, yeah, that's the same thing. The order doesn't matter. I can see that 3x squared minus 4x plus 5 is the same as 5 minus 4x plus 3x squared. But when we set up our long division, we always want to have our biggest number first, then our second biggest, then our third, so we need to write them in the right order. And that's why we highlighted this right here. It needs to be written in descending order. And we'll see that in example 1. So here's example 1. It is not written in the right order. So we take some time. We're dividing by x minus 1. The biggest value is 2x cubed, then 3x squared, then 2x, and finally plus 5. We need to write that in the correct order so that when we start, and we're looking from left to right, we can clearly see that 2x cubed is our biggest value. And if that's our biggest value, what would I have to multiply x minus 1 by to get a 2x cubed? Can you see it? Tyson, pick someone who you think sees it. Well, and I guess take a wild guess. Oh, okay. Pick someone else. What you would have to multiply x minus 1 by to get a 2x cubed. There's a couple behind you. 2x squared. Right? Because if I multiply 2x squared times x minus 1, will I get, what's 2x squared times x? I get 2x cubed. And if I multiply 2x squared by the minus 1, I also get a minus 2x squared. But our goal is to get that first one to be the same. And the reason we want to get it the same because when we subtract, which is the next step in long division, our 2x cubed minus 2x cubed will be 0. And our 3x squared minus a negative 2x will be plus 5x squared. And the other values are just minus 0, so they'll just come down. And now we repeat this process. We now have a new biggest term. It's 5x squared. So Tristan, pick someone. In this case, now it's 5x squared. What would we have to multiply x minus 1 by to get a 5x squared? You got to pick someone who you thinks got it now. You'd have to multiply by a 5x. So a 5x times the x minus 1, well, 5x times x, sure enough, there we go. We got 5x squared. And the 5x times the minus 1 would be minus 5x. Again, put it in brackets and subtract. And this is 0. Negative 2x minus a negative 5x will be plus 3x plus 5. And the reason I've color-coded this is to show you that what we did when we wrote the black stuff is the same process that we did again when we did purple. And now we're going to do it in green. What's our biggest term now? It's a 3x. Ryan, pick someone. What would I have to multiply x minus 1 to get the 3x? By 3. So, and because it's a 3, I'm writing that above the 3's, the 1's column there. And 3 times x minus 1, sure enough, it'll be 3x. And 3 times the minus 1, minus 3. And again, subtract. The number one place you'll make mental math errors is in the subtracting. And for whatever reason, when you're very close to the end, you let your brain off the hook a little bit, the most common place to make a mental math error is right on the very last one. You're so close to finishing, you're going to just see 5 minus 3. You're going to write 2 here without thinking, but you have to be careful. It's 5 minus a negative 3. The remainder will be 8. And there is our answer. So try some of these because you need to become experts at long division, 3 ACD, and number 5.